This is the first part of how to convert Rhino model to a Revit series. I'm going to use one of the Grasshopper plugins called Revit. This is a perfect starting point if you haven't done this process before. I'll show you the basic components like pushing wall or floor elements and creating a roof using adaptive components. Without any further ado, let me show you how to push this Grasshopper Courtyard Pavilion from Rhino to Revit. Okay, we'll need to create a base geometry for a courtyard pavilion, so type rectangle. So you'll have a rectangle base. We'll have to set the XY parameter, so type 10 for X parameter, type 25 for Y parameter. We'll have to offset to create a courtyard, so let's type offset curve. So this will become outer line since it goes out, and I'll give 2 meters. So this is literally be a, the walkway or the corridor type of courtyard pavilion. And next you'll have to do is moving these two lines up. So first we know the outer roof has to go slightly higher up. So you'll type move, give set vector, type these two, connect these two together, bring it slightly down to give a space, connect that to rectangle and type 5, which will go up by 5 meters. And I'll make a group to make it visible, say internal wall height, and we'll do the same, grab whole thing, copy paste, do the same thing for the outer wall. Inner wall can get down to 3 meters, and let's connect it to see whether it generated a nice pitch roof. Type loft. We're gonna loft these two lines, connect these two, and you'll have to flatten this. And next you will have to do is that you will have to loft these two to connect these two lines up and down. Simply type loft, and you connect that to there and that there too, as well as you bring it out, connect that there and here. So now you have just completed a very simple courtyard pavilion types. If you want to create a more interesting, the space or the geometry, you can create internal courtyard to have an overhang of the roof. So to do that, okay, let's do that now. To do that, you will need to grab that to offset and offset that. This time you'll have to go distance and right click expression -x to go reverse. Type 1, so you want to create a 1 meter overhang. So this is the internal wall. You can leave that. So this is the pitch roof. So what I'm going to do, I'm going to disconnect that. Hold down Control and go back to geometry and hold down Shift to reconnect to there. Now you just have a created overhang of the roof structure. Right, let's take a look at what Revit has got to offer. So first of all, you're going to use Revit wall to push the wall to Revit. Second, you will need a floor. So I'm going to grab Revit slab. So I'm going to use a slab to create a floor. Thirdly, we are going to use adaptive component to create a pitch roof. I will explain to you one by one now to just go through the fundamentals of these 3 different components. Obviously, there are more components to explore, but since it's the basics that you're going to use, and these are the most commonly used features and the components in Revit 2. So let's start from these 3 components. To generate this wall, you will need a baseline. So we have these baselines. We created this baseline from the beginning. So we have these 2 offsets. So let's create the external wall first. So we know this is external wall. connect that to baseline. You need to grab type and level bottom, which will be the starting point for the extrusion of the wall. Height, you need to collect the height of the external wall. Join, whether you want to join the walls or not, and flip. You can also decide whether you want to flip the wall. Parameters, you can also push the parameters that's been generated in Grasshopper to Revit. The fundamentals that you need to remember is that you just need the baseline, type, level bottom, and height to make it work. So I'm going to use these four first and then do the rest later. So type, you'll have to go back to Revit to check what type of wall families you have. To do that, you have to launch the Revit and go to 3D view. To test it, go to architecture, click wall, see what you have in drop-down menu. So these are the wall types that I have in my Revit, but you'll have to check this in your Revit too. Sometimes you get different wall family types. Just drag in the arbitrary space and click the wall, and it says generic 150. So this is the wall type that I'm going to use. So remember, you have to have this correctly. It is capital sensitive, so you'll have to remember to copy exactly the same name. To do that, either go rename and copy this, and you can paste it back there, or just type it manually. Before we go back, go to graphic settings, VV, and go to annotation categories and go all the way down to levels. Turn on levels and check what levels you have in Revit 2. So we have level 0, interstitial level 0, and level 1. Okay, so that's all you need to remember, and let's go back to Rhino. So back in Rhino, type the family type, so underscore generic hyphen 150. That's the wall type that we have. Go click to type and control paste, and we know what level we have. So starting level will be level 0. Connect it to bottom level. The height, go all the way back. We know this is the height, which is 5 meters. Other thing that you have to remember before I connect that to there, Revit, it has got different unit setting to Rhino. So you'll have to convert this height from metric to imperial. Quick check that will be go to Google and convert, so meter to feet. If you type that, it will give you the number, the vector that you will have to multiply by. So control C, go back to Grasshopper, and you want to drop that panel and put 3.28084. You can round it up, in fact, that it doesn't need to go down that far. So do it down to 2 decimal points and multiply, type multiplication, and that goes to A, B, and that will give you the height. That feeds back to height. Right, let's check whether this component works or not. So go to assemble and go all the way down to Revit send and connect that to components, and you'll need a Boolean operation type button. Connect that to send. Okay, go back to Revit again. You'll have to remember is click Grevit first in Revit space, go back to Rhino Grasshopper, click that button. You should have now have pushed that geometry, so you can see that the outer wall, the external wall, has just been pushed into Revit space. I'm going to delete this and complete the rest of operation. Go back to Rhino, and I'll do the same thing. So move quickly down to Revit slab. So slab requires a surface, but we don't have a surface for the floor yet, but you know how to create those. So type loft and connect these two curve lines. You you can see that hasn't, so you'll have to flatten this. Now it's been generated. And you know what you get once you loft it, you normally get BRAP. And let's connect that to see what you have. So you have open BRAP. So what you have to do, you have to deconstruct this BRAP. So go ahead and do the deconstruct that. And now you have 4 different faces. So this is all you need, and connect that to face. And like what we did for the wall, you need a type. So go back to Revit to check what floor type that you have. Go back to architecture, click floor. We have generic 200 and concept 300 and generic 300. So I'm going to use generic 200. Remember, you'll have to use the exact same word for word to get it work. So go back to Rhino, and you have to type generic hyphen 200. So double click panel, generic hyphen 200. You can always go to the type and grab that name precisely and paste it into panel. So I just got that to 100, and the bottom level, we know what the bottom level will be. Control this panel and paste and bring it all the way down. Connect that to level bottom. Now this is good to go. So hold down shift, go all the way up to Revit send. So this is ready to be launched. Lastly, I want to show you how to create this pitch roof. The reason I selected this adaptive component is that if you use just normal Revit roof, you won't generate that 3-dimensional pitch roof. So we'll have to come up with points to make it work. And I know this will be open BREP as well. So we'll have to deconstruct this. So deconstruct BREP. And this will get you 4 different faces and vertices. And to get the individual points of individual faces, or these 4 faces, you'll have to deconstruct it again. So Control V and paste it and connect that to faces to BREP. Then now you get, if you get panel, 4 different untrimmed surfaces, as well as 4 different sets of point lists. So that's what we need, and that goes to points. Okay, now we'll have to go back to Revit and generate that adaptive component in Revit and create a family. So click family and adaptive component Autodesk. Go to metric generic model adaptive. Open that family. So since we know that we need the 4 points to generate that in each individual faces, I'll grab these 4. I'll grab points to drop 4 points. Select them all. Go to filter, check none, and only select the points. And you'll have to make these points adaptive. And what I'll do, I'll go to reference and click line, and you'll have to make sure that click 3D snapping. Start from 1, 2, 3, and 4, and go all the way back and escape. Now we generated a base, and we'll have to create a form. So go under create form and create a solid form, and we have just created a slab. You will have to give a parameter. So what I'll do, click that, go all the way down, click that, dimension, create a parameter. So whether you choose to go with the family parameter or shared parameter, it depends on what you want to do. If you want to create a schedule, then you can choose a shared parameter and then create your shared parameter within the project. However, for demonstration purpose, I will stick to family parameter and just type themes or depth 1, D1, and I'll get that to type and select OK. And if you go to that family type, I'll change that to 100. So I want that to be 100. And I'll do the same process again. Since I want to get it nicely offsetted bottom and up, and I'll generate a solid form again. And that's done, and create another one. Select the theme. You'll have to select the theme again and create another one, which will be D2. Family D2. Click OK. Push it all the way back there. D2. That goes to 100. There you go. So now we have 100, 100 equal offset. Now go and save this. Save. I'll save it to my desktop. Type Revit roof. Okay, and push it to the project. And now it's been pushed in. To check this, whether it's been loaded into Revit, you'll have to go all the way down. Generic models. Grevit roof. Okay. Go back to Rhino again. You'll have to give family name, which we know is Grevit roof, and type is the same. Okay, so ready to go, and that gets connected all the way up to component, and we should really good to go. Back to 3D model, and go to add-ins, activate Grevit, back to Rhino, push it, go back and check. There you go. We now have generated a pitch roof and wall and internal wall. So let's go and do a little more. Create a section box and create a section. Oh, we haven't pushed the internal wall yet, but that can be done separately. Go back to Rhino. Where is internal wall? So this is internal wall, so you know what you have to do. You can just copy exactly the same thing, push it back, but this time you'll have to push this number and copy that and paste. So this is, remember, multiplication that we did with the wall, external wall. That A needs to be swapped and result goes to the height. So to distinguish these two walls, I will name it to external wall and that to internal wall. Okie doke. Hold down Shift and connect that to component. Rhino. Remember, the internal wall needs baseline, which baseline is that. So this is baseline of internal wall. This is external wall. Go to Revit again and drag it. Rhino, push it back to Revit. It should all been transferred. Plan. One, yes, here you go. Internal wall. You have the floor slab, external wall. So that's it for the fundamental, and I'll cover the more tools like creating a curtain walls and more adaptive features. Thank you for watching and see you in Grevit Part 2.